Hello, everyone. Thank you for tuning in to the amazing podcast. It's great to have you with us. And we cover all things Kubernetes, cloud native. That's what we enjoy talking about. And I think that's what you enjoy listening as well about. Uh, I'm Twain Taylor, editor at Amazing. And if you like what you hear on this podcast, go and check out our other stuff. I think we've been doing this now 2+ years. So we've covered so many organizations, open source projects that you really want to catch up on the previous ones as well. So go and check them out at amazic.com. That is amazic.com. Today, the topic is authorization. And we have someone who we've had in the past, about a year ago, I'd say. We featured this startup named Cerbos, and they were pre-launch back then, pre-GA at least, and still refining their product. And that's when we spoke to them, and they gave us a sneak peek, and yeah, it was quite exciting to talk to them back then. But today, they're really excited because they've just had their big launch just 2 weeks ago. And so we wanted to get them on the podcast and get them to tell us all about it and what's new, what's been cooking since then. So I have with me today Alex Olivier, who is the co-founder and chief product officer at Cerbos. Alex, welcome back. It's great to have you here.
Hey, Twain. Yeah, thank you for having me back. Always happy to chat with you, and it's been an exciting few weeks, so lots to talk about.
All right. So yeah, tell us about the launch. How did you launch, and what was special about the launch?
Yeah, absolutely. So the very first time we spoke, I think, it was over a year ago now, probably. We had been working away on our open source project. So Cerbos is a open core company. So the core engine for authorization, which is Cerbos, is completely free, open source, being out there for nearly 4 years now, which is kind of scary. And what we've been working on for the last year or so has actually been a management layer that sits on top of the open source project. So before diving into that, I think it's probably worth framing a bit authorization, what we actually talking about here, because unfortunately, authorization sounds very much like another word, authentication, and it's sometimes very easy to mix those two up. So
Z and auth.
yeah, that is the problem, because it gets shortened to auth C and auth Zen, and sometimes even I get muddled. So what we're talking about here is authorization. So when we talk about authentication, auth N, that is the process of which some system will challenge you to provide a credential, username, password, and you get back a verified identity that says, okay, this person is who they say they are because of some challenge they had. Authorization is the next step after authentication, which is, okay, I now know who the person is. Yeah. What are they allowed to do? Should they be able to hit this endpoint? Should they be able to edit this resource? Should they be able to go and do X, Y, Z inside of the system? And that's the challenge that authorization and the challenge that Cerbos has been kind of working in. And our open source project is what's called a policy decision point. And there's all sorts of formal nomenclature around the space, standardized by NIST a good number of years ago now. But when you talk about authorization, there's a few different components involved. You have a policy decision point, a policy information point, a policy enforcement point, and a policy administration point. So to quickly rattle off what those things are, a policy decision point is a component inside of a system that will get asked, can this user do this action on this resource? And it decides yes or no. A policy enforcement point is the part of your system which actually takes that yes or no answer and enforces that decision. So in most cases, this is typically inside of the application or maybe your gateway level. Policy information point is a system that provides the context about the user or the resource they're trying to access to lead to the decision making. And then a policy administration point is where you actually go manage and define and control your policies. And that's the product we've just launched into GA.
Oh, okay. So sounds like authentication is simpler because it's probably a one-time thing. It's probably just maybe even a couple of times, but then authorization seems more complex because it comes up at every turn and corner of the cloud native stack. Would that be correct to say?
Yeah, exactly that. And I would say maybe up until fairly recently, you're right in saying that authentication is kind of a one-off process that you then get a token or a cookie or some sort of identifier which is valid for some time period. You know, if you're using JSON Web Tokens, JOTs, you'll not be familiar with like the expiry timestamp that's inside of those tokens, which tells you how long that token is valid for. And that can be done at the start of a session or refresh that halfway through a session, etc. But you've got some sort of key or some sort of credential, and that's kind of valid. I would say there is actually much more of a movement recently around doing more continuous authentication as well, where you actually much more
Okay.
aggressively verifying the credential, but that's, I wouldn't say commonplace right now.
Okay.
But yes, authentication generally is a process that you can do once, then you essentially kind of cache that credential or have a long-lived credential that goes around. Authorization, particularly fine-grained authorization, which is the space Cerbos plays in, is something that needs to be done at every single API call or request or method action that occurs inside of a system, because it's very contextual, not based on just the user's identity, but the specific instance of a resource that, say, you're trying to access, Twain. So your request comes in, attached to that request is your identity, your credential, and then based on the API call, you're trying to do a particular action on a particular resource. So if you just want to speak in like HTTP verbs, you might be doing a post or a patch or a delete. That is an action, and you're doing that action on a specific instance of something. So it could be, you're posting an article on amazing.com, you're trying to interact with a article object inside of the system. And to make an authorization decision, it's going to be contextual based on who you are and the specific instance of a resource that you're trying to do that action upon. So maybe you have a rule inside of, say, a CMS that only the author of an article can delete an article. So now you need to actually now know who you are, the specific article you're trying to access, some attributes about it. Is the state of this published and who was the owner ID, and then make a decision based upon that. And so authorization has to be done in every request, and more importantly, it's in the blocking path of every request. So performance is key around how you quickly your system can generate those decisions inside of your application.
Performance and even security is the ultimate thing that's at stake. I'm curious to know about one thing, which is just this perspective of humans versus non-human identity. Does that come into play at all when talking about authorization? Does it change when you talk about authorizing human users versus, things like components, different components, and non-human? Could you talk a bit about that?
Yes, this is actually a really interesting space that I think is gaining a lot more focus right now. It's always been a concept that's been, in the background, but I think recently there's been a lot more in terms of the things we're being asked by our users around how to kind of best support non-human identities, and there's even a whole companies spinning up to do focus just on that particular area. And at the actual decision level, when your system needs to decide, can this request with this identity do this action, it's actually exactly the same, because a lot of the formal literature talks about a subject or a principle. That doesn't necessarily dictate that this is a human. It's just an identity. That identity has an ID. It's got some attributes associated with it, and you can make decisions the exact same way, whether it's a human or not. I'd say that the bit that is different when it is a non-human identity is those identities or those kind of credentials are more typically longer lived. Because you can't necessarily, you can't get like a microservice to go through an authentication flow. You generally kind of issue that service an identity and give it some credential, which is valid for typically a longer time period. And you can't just go and re-authenticate them because, a service can't go and necessarily log into a UI and enter username and password. So obviously it's a very different kind of credential. But at the core of it, when you're trying to make an authorization decision, whether that is a human or a non-human identity trying to do a call, it's kind of irrelevant. It's just an identity or a subject is trying to do some system. And with Cerbos, we have a case study with a company called Utility Warehouse here in the UK. They're one of the largest utility providers, part of Telecom Group. They're a multi-billion-dollar publicly listed business here. They have 4,500 microservices, and they're using Cerbos to authorize requests between them. So doing service-to-service authorization and also sort of delegated access. So the end identity is actually passed down the chain of requests. And to Cerbos and really to any policy decision point, if that identity is human or not, it's kind of irrelevant. It's just, here's an identity, here are their attributes, they're trying to do this action, should be allowed or not.
So yeah, it's just a lot more bigger scale when it's when you're talking about non-human identities.
Yeah, and there's some great kind of other open source projects out there. If you look at how to issue identities to services, so Spiffy and Spire, the kind of Google white papers that came out around how they do identity inside of Google, has spurred a number of kind of businesses off the back of it. And we kind of see an intersection with Cerbos with those around consuming those identities in whatever form they are, but typically it's just a JOT token.
Okay, okay, all right. Yeah, we have a lot to talk about, especially with what's been happening recently, both with Cerbos and in the industry. I want to talk about starting with just Cerbos itself.
Mm-hmm.
Saw that there's a bunch of new features. One of the interesting ones that I saw you had written a blog post on is the Dagger module. What is this new feature? What does it do, and why is it important?
Sure, yeah. So Cerbos, as I mentioned at the start, at core is open source project, and we've been really kind of embracing different workflows and different ways developers kind of interact and build their policies and manage their pipelines and those sort of things. So the core of Cerbos really is a GitOps style workflow where you have your policies as a static asset in a GitHub repo, let's say. You work in those policies which define your define your resources, your actions, and under which condition those actions should be allowed. You can be a simple role-based check, or you can do a more fine-grained attribute-based check. And fitting with the GitOps principles as well, we also allow you to write tests against those policies. So as well as defining, here's my resource policy, here are the actions, and here's when things should be allowed, you can then also write your test cases and write your test suites. So under you include in your policy set a set of example principles or subjects, example resources, and then define what the expected actions are allowed. And we have CI tooling and such to do it. Now Dagger, if no one's familiar with it, is another great kind of open source project and company behind it as well, which is a way of kind of orchestrating and defining those very rich pipelines for doing your CI processes. So rather than writing those big sort of YAML GitHub action type CI pipelines, which get bigger and bigger and bigger, Dagger allows you to actually do it through code. So they have like Go bindings and JavaScript bindings now, I think, as well, and a few others. And the idea is you kind of putting together a DAG, directed AC graph, hence Dagger. And there's a kind of a rich ecosystem around it. So we worked with them to kind of build out a Cerbos module. So what this then means is if your pipelines are using Dagger for defining the graph of CI jobs to run, you can drop in Cerbos in there and you can then run your Cerbos tests as a Dagger module step. But also we provide a mechanism where you can actually then spin up a Cerbos instance within your Dagger pipeline, which answers kind of one of the questions we get a lot, which is how do I do sort of end-to-end testing when Cerbos is involved as well? And so what this allows you to do is actually spin up a Cerbos instance for the lifetime of your pipeline when it's executing, and actually run requests through your application and actually hit a real Cerbos instance behind the scenes to kind of do that end to end. So the Cerbos tooling allows you to do the very simple, well, not very simple, but the actual tests of your policies, and then you can also use what we call the Cerbos run module to then actually run a real Cerbos instance and actually do end-to-end sort of integration style testing of your application using a real Cerbos instance behind the scene. And the Dagger module is published in the marketplace, the Daggerverse, I believe, Daggerverse. I guess marketplace is the word, but sort of showcase, and then you can pull that in and pull it into your Dagger pipelines, and it makes it much easier to work with Cerbos inside of that environment.
All right, neat. Wow, so just easier management for policies at scale.
Exactly.
That sounds interesting. Is there any other new feature or addition to Cerbos itself in the past few months that you'd like to mention, that you'd like to talk about?
Yeah, so in the core Cerbos open source project, before we come on to Cerbos Hub, we've been adding a few new capabilities that have really come up through working with our users. The first one is actually around what we call policy outputs. So typical policy decision points, you ask it the question, can this subject do this action on this resource? It evaluates your policies, comes up with a decision, and gives you back an allow or deny. You get a Boolean, and that's kind of it. Now, there's a whole class of authorization checks where actually just getting an allow or deny isn't really enough. You need a bit more context. In, again, sort of the classical case, classical architectures for these kind of systems, this is sometimes referred to as advice or obligations. And it's a mechanism from which your decision point can actually return not just an allow or deny, but it can return some other metadata or other output to the application layer or the enforcement point for it to make some decision. And what policy outputs allow you to do is when you're writing your Cerbos policy, as well as defining the rules under which an allow or deny is should be returned, you can also then define an output alongside it. And this is kind of free form based on you as a policy author to define. But one of the first kind of use cases that one of our users came to us with, and we ultimately ended up building policy outputs around, is they wanted to be able to tell the application layer when an action is denied, but it would be allowed in the case that someone does a step-up authentication. And the actual use case here was it was like a fintech type platform, and they wanted to put limits in place where only transactions over a certain amount are allowed if someone has done a 2FA check within the last 10 minutes. So the Cerbos policy says if transaction amount is over $10,000, let's say, and the last two-factor authentication step up happened in the last 10 minutes, then the action should be allowed. In the deny case, we have a policy output that replies deny, reason being 2FA required. So it will say, okay, it passed the threshold test, but it's failed the 2FA check. So what comes back to the application is a deny and then a payload which says encoded as like an error message that a 2FA is required. And then the enforcement point, so the application layer at this point, knows how to interpret that response and redirect the user off to the authentication system and trigger that step-up authentication. So do the 2FA, one-time password, those kind of things. And what then comes back is the request going to be repeated. Cerbos will now allow it because the attribute that says when the last 2FA occurred has been updated, and now this policy would allow that request to go through, and the application then proceeds at that point. So it's a mechanism via still writing policies. You're still doing version control, auditable, testable policies to return more than just an allow or deny, but return an output or some advice or an obligation back to the application layer or the calling system to then perform further actions all driven by your actual policies.
Interesting. It sounds like it's a good complement to the previous thing we just spoke about. It seems like the Dagger module is more end-to-end, top-level management, but this one, policy output, seems to get into the weeds and give you more detail about each policy, and just gives you like a closer view of what's happening. Really cool.
Exactly.
Yeah, you're going to say something?
Yeah, the kind of those use cases really kind of vary. So I mentioned the kind of the 2FA example. The other one we've seen in the wild as well is using it to do IP range restriction. So the only thing you must be on like the corporate VPN range for actions to be allowed. You can return back an error message saying it was denied because IP range restrictions. The other one we've seen with like a call center help desk type system is only allowing certain actions within office hours based on that person's profile. So again, using that context and then returning a message why rather than just a flat out deny. And then this flows into the audit logs as well, which is something that's baked into the core of Cerbos. So every decision that a decision point makes gets logged. This principal tried to do this action on this resource and it was allowed or denied by this particular policy and produced this particular output. So it's all a kind of a holistic system in terms of policy authoring, testing, making decisions, getting outputs, and then capturing those outputs as well inside of the audit logs, and gives you that full visibility of exactly what's going on inside of your system.
Mm-hmm. Well, neat. There was another interesting blog post that I saw on your website talking about sidecars. It's titled "What's So Bad About Sidecars?" Quite a provocative title, and considering we're coming from times when sidecars were lauded as the best thing because they took load off the containers themselves, and they gave you a separate management plane with things like Istio and all of that. So now we're talking about, are sidecars really that good? There are some drawbacks to them. Sounds like that. Could you tell us a bit more about that blog post and tell us about sidecars?
Yeah, so sidecars, we're talking here in the Kubernetes context. When you have your pod, and inside that pod, you have your main sort of service container, your application container, and then optionally you can have n number of additional containers that run alongside it. And Kubernetes guarantees they're all running on the same node and they're all talking on the same sort of interface, etc. Now, as you mentioned, like Istio, there's been kind of a shift in how these service meshes approach, where before it used to inject sidecars into every instance. The downside with that is now every service inside of your cluster needed more compute resource because every instance of each pod now had more compute going on inside of it, and thus the load on your overall cluster is going to increase because you just have more containers running. And they did all the high sidecar injection stuff. Moo's been kind of moved away a bit from that, and sidecars mainly for that kind of overhead and sort of management complexity have kind of been pushed aside somewhat, and these ambient mesh type approaches and stuff like that around. Now, with authorization, sidecars are actually a perfect use case, we believe anyway, because going back to my earlier point around speed and security really is key, because authorization checks are in the blocking path of every single request. The way Cerbos is architected is Cerbos decision points, the component you run inside of your system that you ask, can this user do this action, this resource, are fully stateless. The only thing that's pulled into those are the actual policies when they start up, and then kept up to date. But there's no other state involved in terms of you don't have to go to database, you don't have to go to disk, you don't have to go to network or anything like that. All the decisions are being done in memory and being processed based on the request that comes in from the enforcement point to the decision point, along with any context, etc. So what you really need to optimize for, because this is in the blocking path, is reducing as much as possible the network from your service to the decision point. And sidecars are a perfect use case for this because Kubernetes then is running those inside of the same pod. They can talk over localhost. You can even use a Unix socket directly using our SDKs to talk to the Cerbos instance. And it's all about removing as much overhead as possible between your application and your decision point to come up with a decision. If you even look at how we built Cerbos itself, the primary interface it exposes is gRPC, so much faster than regular old HTTP REST style approaches. Talking through a socket skips a couple more layers as well. And we always kind of recommend anyone that is using Kubernetes through application deployment to use Cerbos in a sidecar model as well, because that way you don't have to worry about scaling Cerbos. Because as your application scales, because it's a sidecar, it will scale with your application, and each instance of your app will just talk over localhost inside of the same pod, guarantees it's not hopping to another node, or what you never, ever want to do is have to go like over the internet to an authorization check. That's just a terrible design architecture and is going to add immediate latency to every single API call. With the Cerbos approach, Cerbos comes up with the decisions sub-millisecond. Anything else is basically network. So using sidecars, you can ensure that your application and your decision point are co-located, and you're going to get the best performance possible when it comes to doing an authorization check and making sure that that request goes through in a timely and responsive manner. And you just don't really have to think about where am I running my PDPs. It's just always going to be co-located. So I will always fight the good fight for sidecars, because I think it's a great pattern for this specific type of use case. I think the service mesh and that kind of ecosystem, maybe it wasn't the best pattern, hence things have moved away. But for these kind of things, it really does fit the mold very well in terms of how you want to deploy something so key as an authorization decision point inside of your architecture.
Okay. So kind of it depends kind of a response that I hear. That's interesting. Yeah. I want to take a step back and talk a bit about the ecosystem of authorization with so many open source projects, so many vendors taking different approaches to authorization. The question of standardization comes up. And I wanted to ask you about, what are some of the efforts in that direction to standardize things so that, we eventually avoid lock-in, because that's something nobody wants. So talk a bit about that. What some of the efforts being made in terms of, vendors working together, standardization being set up.
Yes, this is a really exciting time when it comes to kind of the authorization space. Cerbos is part of a OpenID working group called AuthZen, which is an effort to do exactly what you were saying. So standardizing the interfaces on which authorization components talk to each other. And this was kicked off about a year ago now. And when we look at kind of the broader vision of kind of where authorization needs to be, so the authentication piece today is kind of solved. We go and look at OpenID Connect, OAuth2, those kind of things. Those are standardized, adopted systems, and you can go to any sort of platform of decent scale and go and plug in your own identity provider. Take like Salesforce, for example. You can go and do federated SSO, those type things. You as a business keep your identities inside of your own system, and you federate those identities out to said system. What there isn't today is a mechanism to do essentially federated or single sign-on-esque type workflows, but for authorization. So if you go and look at a Salesforce or an SAP or kind of one of these type systems, You can go and federate your identities and have single sign-on where your authentication is kind of brokered and using OpenID Connect and these kind of mechanisms. Your authentication is basically externalized from the system you're using. But you then have to go into an SAP, Salesforce, etc., to go and configure, okay, now you've got an identity, a federated identity in. How do you then go and assign those groups and roles and permissions? You have to go and do that inside of the actual system. There's the SCIM and various other mechanisms for doing directory sync, but the actual assignment of application level permissions and access controls around those has to be done inside of each application. So when you look more broadly, if you want to get to a world where you could go to, I keep using Salesforce as an example because everyone knows it. If you go to a Salesforce and you're provisioning a new Salesforce setup, you would go and connect your authentication system. And we also want to allow you to basically go and then connect your own authorization layer as well. And the only way we're going to get adoption with these large, big companies is to actually making sure there's an open standard for what that interface looks like. And that is the effort of the AuthZen working group. So it's been going for about a year now. We're at a draft implementer stage. So we have a first spec out there. You can go and find it on the OpenID website. And Cerbos, as well as 11 other vendors, are some of the first implementing vendors for this specification. And what that spec has done is formally defined the interface from which a policy enforcement point and a policy decision point talk to each other. So we've defined the interface where an application layer or an enforcement layer talks to a decision point, and we've defined the spec that defines the principal or subject, action, resource, schema. It's actually a JSON payload type schema, and how that then talks to the policy decision point, and then also define the response format back to it. So back at Identiverse, which is one of the big kind of industry conferences around this, and also EIC in Berlin the following week, myself and then our friends and other vendors in the space, we all kind of came together and demonstrated through a single demo application a simple to-do list type app. And with that, we could then actually connect it to any of the 12 implementers that are out there. And mid-session, we could actually change which decision point the application was using on the back end for each one of these different vendors. And the application kept working. And that's because we've all kind of implemented this first working draft of the spec. So Cerbos is part of that. We are kind of working with everyone else in this space around defining that specification. There's work going on now. You can find all the recordings and the notes on the OpenID website as well. Look for the AuthZen working group around defining the next thing. So we're looking at how to do batching and boxcaring and then defining sort of the advice and obligations that I was talking about earlier. These are all things that are very much in scope and coming up, and we as Cerbos are very proud to be taking a part in that and working with our peers across various different vendors. And if you're on the other side, if you're a systems builder or you've got kind of use cases around authorization, I really encourage you to come and join this working group in these sessions, because we're really looking for more use cases and real world scenarios of the kind of things that this spec needs to be able to support in order for us to kind of get broader adoption. You can read more about it on the Cerbos website, but I also encourage you to go and look at OpenID AuthZen working group pages. It's OpenID, so everything's open, funnily enough. Both the spec, the meetings, the calls, all those sort of things.
Oh, really cool. That's amazing how all of the vendors are cooperating to define a standard where you can pretty much switch to any vendor at any time. That's a lot of confidence, and yeah, just really we've come a long way in just cloud native. That's really. What are some of the key open source projects? Obviously, you talked a lot about Cerbos open source itself. Apart from that, what are some of the key open source projects that you think listeners should keep an eye on in terms of authorization?
Yeah, so there's really kind of a few different camps around authorization and sort of how to approach it. With Cerbos, our open source project is really focused around attribute-based access control using a policy-based approach. And I would say the two projects, or I guess the two models that people would have heard about. One is OPA, Open Policy Agent, which if you're using Kubernetes, you'll be aware of. And the other one is sort of the Zanzibar style system. Zanzibar was a white paper published by Google, which basically explains how they are doing Google Drive, Google Docs style permissions, where you have millions and millions of objects and trying to have these arbitrary access models based on roles, groups, assignments, folders, etc., or direct assignments, ACLs inside of the model. And they're really kind of the two camps. And there's a number of open source projects that kind of implement the Zanzibar approach, and then as well as the policy-based approach. Cerbos is one of those. Open Policy Agent was actually the foundation of which we started building Cerbos. It's a obviously a great project. It's adopted by Kubernetes, etc. But it's a very kind of broad project. And what we did with Cerbos is we took kind of that engine and built a simplified policy layer on top. So with Cerbos policies, you're writing just in plain YAML rather than Rego. And then kind of from a performance perspective as well, Cerbos is really targeted at this application level fine-grained access control problem space. So we've really kind of scoped down and ended up sort of swapping out the engine underneath. So we no longer actually use Open Policy Agent. We've got our own in-house built engine, still open source. You can find it all on GitHub. It just gives us up to a 12x performance improvement over the open model because we've really focused and targeted around the application use case. And again, with the policy language itself, put in something that's what we believe is much more human readable and doesn't require developers to go and learn something like Rego, these other solutions. So a number of great kind of projects out there that kind of fall into those camps, many of which are also part of this open standard working group as well. So kind of very familiar with those. And depending on your access requirements, you may need to go and use something that's more Zanzibar based. But if it's more policy based, then Cerbos or one of the kind of other OPA based implementations might be more applicable to your use case.
Oh, interesting. I didn't know that. That's a really good thing to know. Something that someone is really into researching all this stuff should really look into this. There's some really cool background there. So I wanted to ask if you could show us visually, this being a video podcast as well, show us visually some of the things you're talking about around sidecars and just the new things that have been happening at Cerbos.
Absolutely.
Something for us on those lines.
Sure. So just pull up my screen. And because we're kind of talking more about architecturally based, I'm just going to use a couple of diagrams to kind of explain typically how you'd use a policy decision point, and then also where Cerbos Hub, which is our policy administration point, kind of fits alongside it. So if you look at a typical request workflow, and this is applicable not just for Cerbos, but for any sort of policy decision point system that you might use, you have some end user and they are interacting with your application. So they're in a browser or a mobile app, or they're hitting your API if they're a non-human identity maybe. That request comes in and it hits your environment, hits your infrastructure. This being Kubernetes based, this is your cluster. Request comes in, probably goes through some sort of gateway type system. And then at some point, it's going to hit your actual instance of your application. So you've got all that routing layer and it's going to hit a specific pod inside of your cluster. And inside the application, at request time, you essentially know two things. You know who the principal or the user is, and you know what resource they're trying to hit and sort of the action they're trying to do against it. So in your application layer, you're probably going to have a token of some sorts from your identity provider. Maybe you go out to a directory type system or go and enrich the token with some extra metadata, say what teams or groups someone's maybe a member of. Your application kind of knows. And then your application or your service being responsible for the actual resource they're trying to access knows how to go and query its own data store and go and fetch that record. So to use your, the amazing CMS, for example, the service that handles editing blogs knows how to go and grab that from its own database. And now in your application layer, this is where you typically then have that logic that says, okay, if the user is the owner, they can do the action. If they're the manager, they can do the action under XYZ scenarios, etc. And that logic is typically sort of hard-coded. What externalized authorization, which is what this whole kind of space is called, does is it extracts or externalizes all that logic out into a standalone policy decision point. So in Cerbos, as we talked about earlier, we recommend this running as a sidecar inside of your environment. So here we're actually talking inside of an individual pod. And in the application layer, you package up that information about who the principal is, who the resource is, what action they're trying to do, and send that over to that decision point. So in the sidecar model, that's just a local host call. That decision point has loaded into it the policies. So in Cerbos world, those policies are those YAML definition files. You store them in some sort of store. We support multiple backends, but the one most users go is they go and just have a GitHub repo that holds their policies, or it's just another folder in their application repo. And when that policy decision point starts up, you connect it to where those policies are stored. So in the case of GitHub, you give it a credential to your GitHub repo. It goes out, pulls down those policies, loads them in, and then it's ready to start serving. That repo that holds your policies can also, as talked about earlier, can have tests alongside of it, and we have other tooling and sort of a whole policy editing playground as well available. But at the core of these kind of policy files that are loaded in. Now, inside that decision point, when that request comes in, can this principal do this action on this resource? The policy decision point now goes and evaluates those policies. With Cerbos, it's stateless, so it's not having to go and query a database or hit disk or network or anything. It's making that decision based on all the context that you're giving it at request time from the enforcement point. The policy decision point evaluates the policies, comes up with a decision, and allow or deny. Optionally, also some of those outputs as well. Creates a log of that decision. So you have this permanent log of this user tried to do this action on this resource, and it was either allowed or denied by this particular policy. And then what comes back to the application layer is that allow or deny with some metadata or outputs, or you can even do a kind of query criteria response, which we'll talk about in a second. But ultimately, what this now means in your application layer, through directly calling the API or using one of our SDKs, what you get back is that allow or deny. So in your application code before, where you might have had all this hard-coded logic where it's inspecting the user's roles or groups or attributes, it's now a single if statement. If the decision point says allow, do the action. If not, return some sort of error to the user. So what this really also means is, because we've externalized all that logic out, is these policies over here can change and update, and eventually your policy decision points will get that change through. And now the next request that comes to your service will now be getting a decision back based on the latest policies without you having to touch or redeploy the application service over here. So it really has externalized that out. Yeah. Now with Cerbos, there's actually a secondary endpoint. So we generally the use case of, can this subject do this action on this resource? Yes or no is the kind of the typical interface. But with Cerbos, we also have what we call a plan resources call, which is for the use case where you want to sort of filter or your database query or show a list of resources someone has access to. What you don't want to do is have to go and query every single record from your database and then do a check for each individual one, because you could have hundreds of thousands, millions, billions of records inside your data store, and that's going to be highly inefficient. So Cerbos also has a second endpoint, which we call the plan resources, where you can say to your application could say to Cerbos, I have this user with these attributes trying to do this particular action on this kind of resource. And what Cerbos then does is kind of a partial evaluation, where it goes through your policies and works out which conditions it can evaluate and which ones it can't. And what then comes back to your application is what we call a query plan. And a query plan is an abstract syntax tree of conditions for you to then apply to your database lookup or your Mongo filter or your DynamoDB lookup or whatever you're using for your data store. And that query plan will say, okay, this attribute of a resource should be this particular value, or this attribute should be boot true. This particular attribute should be in one of these three values, etc. And what Cerbos has done is kind of inverted your policies and given you back a set of filters. And then if you then apply those filters to your data lookup, the results you're going to get back are just the records of that resource kind that user would have that particular permission to do on. And thus you are filtering, you're doing data authorization aware data filtering pushed down to the database level, all driven by your policies. So when those policies change again, the next request to Cerbos, when it gets a query plan back, will be a new set of filters. And thus you're going to get, again, the updated query, essentially the where clause that will return back just the records that the user had that particular permission to. So that's kind of the typical policy decision point flow. In that with Cerbos, everything I just explained is going to be open source. You can see our GitHub up here. You can go and grab it and off you go.
Well, okay. Yeah, that's, I think, a great overview of how it all works. And I think just abstracting and separating the policy management from just the core, like the infrastructure behind, or just from the system itself, makes a big difference. And you can, I like that you can update your policies asynchronously. You don't need to change up how your system is just to change your policies, and it's just there's good separation of duties within the system, and that's really cool.
Yeah, and that's kind of the core of Cerbos. And what we released 2 weeks ago is Cerbos Hub. And so what Cerbos Hub is a administration control plane, a policy administration point is kind of its formal name if you were to look at the formal specification kind of for this area. And what Cerbos Hub is an administration layer that sits on top of those decision points. So architecturally, you'll notice that this is all exactly the same. So your service is running, your instances, how it makes decisions, etc., all runs in your environment using the open source core, etc. What has changed is how Cerbos Hub sits on top and is much more a managed workflow for working with your policies. So Cerbos Hub at its core really does four things. Firstly, it's an environment for you to work and edit in your policies. So it has like a whole collaborative IDE, sort of a la Google Docs style, where you and colleagues can work together on policies, gives you real-time feedback on those changes and updates of what's going on. Secondly, it's a CI/CD pipeline. So Cerbos Hub connects to your Git store, and when you go through and update those policies, it gets that commit from GitHub, it kicks off a build pipeline, and inside of Cerbos Hub, we then go and compile, test, and validate your policies. So it is does the CI parts of policy updates for you. Third thing it does is the distribution. So the challenge that you get, particularly when you're running a sidecar model, is you're going to have more than one Cerbos policy running inside of your environment. And policy decision points running your environment. And when you push out policy changes, you're going to want all those decision points being updated in a timely manner whenever there's a policy change. With the open source projects out there, you kind of have to manage how you push new policies to those instances yourself. Typically, it's just like a polling. So you go and hit GitHub, say, every 5 minutes and look for updates. But that means it's going to take up to 5 minutes for all those instances to get those updates. You end up with kind of inconsistency type problems. So Cerbos Hub has built into it a synchronization and coordination system built as part of the pipeline. So once your policies are built, because all your decision points are now connected to your policy administration point, your Cerbos Hub instance, Cerbos Hub then coordinates the rollout whenever there's a policy change. So all those instances will get notified at the same time that there's an update to your policies, and they'll all go and pull down the policy update, and thus keeping everything synchronized and up to date across an estate of 5, 10, hundreds of Cerbos instances inside of your environment. Cerbos Hub manages the administration and the rollout of policy updates to them. And then the final thing Cerbos Hub does is actually enables what we call our embedded policy decision point. So there's a whole class of use cases where you want to just show and hide menu buttons or items or navigation things inside of your apps based on the user's roles and permissions. And what you don't want to do is have to hard code all that logic into the application itself. So Cerbos Hub produces what we call an embedded policy decision point, which is built from the exact same policies that are running in your backend, but this produces an embedded version of our policy engine. Behind the scenes, it uses WebAssembly, if you're familiar with that technology, so you can basically run it anywhere. And that can then be pulled down into, like, say, an edge function or a serverless function, or even directly onto the device, so in a browser, for example. And then you get the exact same API interface to say, can this user do this action on this resource? But this time it's all being evaluated locally without any sort of network or having to expose any backend services to your application. And Cerbos Hub does the work again to keep that coordinated and updated as your policies change on the back end. So both your back-end policy decision points and your embedded versions are always going to be in sync with whatever your policy store in GitHub holds.
Right. All right. Wow, that's really cool. We're almost out of time, so I just have one more question for you, Alex, about just you wearing your product hat. Just as an entrepreneur, I want to ask about just this journey of going from idea to product that you've launched. Could you share what you've learned through this phase, and how you maybe an example even of how you collected feedback from your customers during the beta phase, and how you implemented that into the final product? Any surprises along the way that you didn't expect? Could you talk a bit from the entrepreneur product perspective of building Cerbos and launching it?
Yeah, absolutely. So because Cerbos is a security system at its core, like, we were very deliberate and careful with how we approach development. And from my previous kind of companies and roles, Cerbos, we actually move at a slightly different pace because we need to be so rigorous and sure that Cerbos is working as it should, and that we're being much more deliberate. And you can kind of see that in what has been the release of Cerbos Hub. We actually first announced Cerbos Hub a year ago, back at KubeCon North America, a year and a bit ago now, that it was available and it was going to be a closed alpha, closed kind of phase. And we got number of our users on that, and we had a very kind of close group testing the very early and very rough versions of Cerbos Hub to get that kind of early feedback. And we went through that phase for about 6 months, and then we did another 6 months of sort of an open beta, and that's when kind of usage exploded. We had 500 odd companies come on and actually be some of our beta testers in that phase, and that's where we kind of got a lot more sort of practical feedback. Very early on, we were kind of working through a lot of the early use cases and trying to understand more the operational side of things. And then in the kind of the more open beta, again, a much more prolonged than previous kind of typical businesses, because we had to be very deliberate from a security perspective, because this is not a system that can break ultimately. And a good example of a bit of feedback we kind of got very early on is people love the idea of this kind of coordinated rollout update system, where Cerbos Hub is the system which notifies all your different instances whenever there's a policy change and things need to be updated, because that was really one of the hard things that we were hearing from the open source usage. So we built this great system. Yeah, so great. Yeah, we built the system. We thought it was great, which then provided this API, and the decision points connect back, and then that is the API as a bidirectional stream, provides the updates, what's going on. And we got users using it, and they were running instances across their cluster, etc. And then as we kind of got closer to kind of production ready and users going to deploy, very rightly, one of our users challenged us and said, "This is great, but what if your Cerbos API goes down? What if, whatever instance, Cerbos Hub sort of falls over? And does that mean my instances won't start anymore? Does that mean my application's down because Cerbos is down?" And we were like, fair play. Yep, that is a very valid concern. And we had obviously built redundancy in our systems in terms of high ability, etc. But this was a moment for us to say, okay, right, we're a security company building security-based software. This thing needs to be as bulletproof as we can make it. And this was a point of failure which we had to go and design around. So we took a decent amount of time to go and kind of rethink and re-architect how that distribution works. So now things are built in such a way that even if Cerbos Hub and our entire infrastructure is down, your instances will still work, and they will pull down the latest versions of policy that was last built by Cerbos Hub. And that's a complete independent system to our deployment of our Cerbos Hub. So we, essentially using CDN type caching, there's encryption of the actual bundles, so they can be publicly available, but only decrypted by your local instances, etc. And that's one of the things that was kind of a completely valid and hard requirement for one of our users for them to go to production with Cerbos Hub, because they need to make sure that they were protected in the case that our systems are down. And that is something that rightly we were called out on, and we went and built and designed an architecture in collaboration with them, which I'm happy to say they're now kind of live with it. And it's one of these things that we had early thoughts of, but it was only really when we were going through this beta sort of phase that we really got to the nitty gritty of it, and decided to pick one of those designs off the shelf and actually go through and implement it based on direct users asked. And happy to say that is now a paying customer, and they're using Cerbos in production because of these kind of fail-safe mechanisms in place. So from my journey as well, we took a much longer and deliberate approach to how we did our kind of early user and beta testing, and took a whole year to go from first launch to GA, because we wanted to get this absolutely right. Because of where Cerbos sits inside of your application, it has to work, and it needs to be stable, and it needs to be up all the time that your application's up. And so we've kind of built around that, and that really is our philosophy with every feature we build. We take longer because we're doing it with the mindset of our end users, where this is a critical component in their entire stack, and that is the hat we wear for every single decision we make from a product perspective.
Oh, that's a great example. Amazing. It was a delight talking to you, Alex. Thanks so much for joining us today and sharing all of that insight. There was just so much to take away about authorization. And just kudos to you guys, just building something really amazing, and even explaining it in a way that it piques interest, I'm sure, of all of the viewers and listeners. So if you guys launch anything big in the coming months, definitely come back and tell us about it. We'd love to keep track of what's happening with Cerbos. And it'd be great to have you back soon for a part 3. All right. And to all of our listeners and viewers, thank you for tuning in, and we'll see you on the next one.